Hey everybody, we're going to continue in our quest to draw rectangles on the screen. Our current project is setting up our vertex buffer. So up here, again, say device create vertex buffer and answer all the questions of what we need. So let's go ahead and look that up. There it is. First parameter is the length of the vertex buffer. It's the size of the vertex buffer. So we have to choose how big it's going to be. So let's say we want, say we're going to allow 128 rectangles to be drawn in a frame. And each rectangle has 4 vertices. And then each vertices is the number of rects times the vert size. And that size is equal to the size of our vertex declaration. So multiplying those all together, we get the VB size. And that's our first parameter. Second parameter, usage. This indicates there's a handful of flags that we can set here, but the big choice to be made here is this going to be a dynamic or static vertex buffer? Dynamic vertex buffer is set up so that you can write it every frame. Static vertex buffer normally represents something like a model that an artist has made. Comes in, the artist places all the vertices, they never change during, they're never changed by code, so you'd use a static vertex buffer there. This is rectangles. We're going to be drawing rectangles at all different points, all over the screen. Rectangles are relatively cheap, etc. We'll use this dynamic. If our game was about drawing 5 bajillion rectangles in the same place every time, every frame, we would use a static vertex buffer, but mostly rectangles tend to move around the screen. Next is a kind of legacy parameter representing what this vertex looks like in the fix function vertex pipeline. We just specified what our vertex looks like for the modern pipeline using shaders, so we can just ignore that one, put in 0. Next is the memory pool that this buffer is created in. Your choices are default and managed, and really, because we've chosen dynamic, the only choice is default. One says, hey card, figure out where you should put this. You can put it either on your card. If your card's on you can put it in AGP memory, which is some memory that's quickly can go from the card to the motherboard. And last, you can put it in system memory. So those are your choices. The DirectX choice managed says have a copy on both the card and in system memory, I believe. And that's it. Take that, set our out parameter vertex buffer, and the last one is a reserved null parameter. And there, we should have successfully created a vertex buffer. Let's go ahead and run it. See if we get a HR OK. Yep, an S OK. And we can go ahead and use it here as well. And we now know what the vertex size is. We just specified that. Go ahead and move that out of this function and call it something better. Fill 2D vert size. And now we have the answer to that. Let's put a breakpoint here. See what happens when we run to here. Ampersand. Still good. And good. We have successfully set a stream. It's a stream of nothing though, so we'll want to go ahead and fill the vertex buffer with some data. Typically, like when we do this the whole way, we're going to fill it every frame. But just to get something going, just to make sure we can draw something on screen, we're going to fill it once on initialization. We have to decide how we want to organize that vertex buffer. So I'm going to arbitrarily decide, and this is total choice, you can do whatever you want here, but our rectangles are going to be drawn like this. This is the order of the vertices within the vertex buffer. So the first one in the upper right, second one upper left, or excuse me, upper left, upper right, lower left, lower right, in that order. To get at the memory associated with the vertex buffer, you simply call lock. And again, if you want to use the vertex buffer for multiple sets of vertices, you could choose a particular part of the vertex buffer to lock. We're going to lock the entire thing. The data, the memory, the pointer for that buffer is then copied into here or sent into here. P vertices. And then there's some flags, and let's go look that up, what the vertex buffer lock flags are. Whoops. Lock. And the flags are discard, no dirty, syslock. We will use discard, and that means we don't care what was in it before. You can throw that away completely when we lock the vertex buffer. And then unlock here at the bottom. So set up what this is, this variable. This variable is going to be of this type, because that's what we've decided our vertices are going to look like. This needs a cast, because that's how C++ likes it. And we should put a breakpoint there, so we can see that we did it okay. Okay, okay, okay. Now we just need to fill out these vertices. And like that little chart said, we'll choose the position and color for each one. Color. And I'll just go ahead and say it should be red. We'll go fill in that constant in a second. And the position, we'll need a vector for constructor. This is an interesting point. Like, so what is that position? That position is in clip space, and clip space means the left of the monitor is -1, the right of the monitor is +1, the bottom of the monitor is -1, the top of the monitor is +1. So to match our little diagram here, we want negative, not quite all the way, and positive, not quite all the way. And we'll ignore the Z order and W parameter for now. Just fill in with nulls. Put this in all the other ones and change the signs where appropriate. So now we'll go to the left. So positive, positive. Bottom corner, negative, negative. Bottom right, positive, X, negative, Y. Pretty cool. Okay, now we need these two functions made associated with our vector for constructor. Float Z, float W. Make that really quick. Okay, and then our constant color red. color constructor. Same thing. It's this pretty much identically. And you know, if you are so inclined, you could template this all up, but I hate templates because I like my types being very different because they're actually different. You know, like adding 2 colors is not even close to the same thing as adding 2 positions. Even though the data types, like the memory looks relatively similar, you know, and this function, this constructor happens to look relatively similar, you know, different. I like when my different data types are really different. So red, G, B, A. Cool. Back down here, set red. Let's go ahead and step through this again, compile and make sure it all works. I forgot my return values. All right, get down to here, still locked okay. Let's check out this memory real quick. For its 6, position looks good, color looks, oh, 1 does not look good because I forgot to change all the indices. Same thing, okay, looks good, 2, 3, 4, and 5th is junk. And cool, okay, pretty good. In the next episode, we'll go ahead and set up our index buffer in a very similar way. Check it out.